Okay, so the last lecture we were looking at differentials, and differentials are a way of approximating a change in a particular problem. So first off, we calculated the differential. That's fairly easy. Okay, so now let's just go back to the linearization of the problem. So when we did linearization, we actually said that, notice this piece right here, f sub x at x naught, y naught, x minus x naught, plus f sub y at x naught, y naught, y minus y naught, is the differential. And it is the amount by which the linearized approximation differs from the true value of something. Okay, so we found the differential of the function. Okay. So say we know f at some x naught, y naught. And we wish to know f at x naught plus delta x, y naught plus delta y. Then the difference, which you can call delta f, oh, that's an ugly delta. The difference, delta f, is f of x naught plus delta h, delta x, y naught plus delta y, minus f of x naught, y naught. But f of x naught I'm trying to figure out how I want to say this here. What did I write here? Okay, so in the differential, I started with that. And so why is this not making any sense to me? F of x naught plus delta x, y naught plus delta y minus f of x naught. That's the change. That is z. Oh, geez. Okay, because I'm what do you call it? Brain fog. Okay, so this is just z minus z naught, where z is f of the new value, where x and y are x plus x. So the new x is x plus some change The new y is y plus some change. And so that's just the difference between z and z naught. But we can approximate this delta f by df. So we can approximate delta f, the actual change, by df, which is f sub x dx plus f sub y dy. Okay, so let me explain. So here's a problem. A box with a square base whose sides are 5 inches each. Has a height of 10 inches. Estimate the volume of the box if the height is increased to 10.2 inches and the sides of the bases are decreased. The sides of the base, that should say base, are decreased to 4.9 inches. Okay, good to go. All right. So now we know that f at x, y is equal to f at x naught, y naught, plus the partial f with respect to x at x naught, y naught. This is the approximate new value. This is approximate. Times x minus x naught plus f sub y at x naught, y naught times y minus y naught. So now in this particular problem, Z is the volume of this box. So Z is the volume of the box. Now the box has a square base. So the volume of the box is x times y. So if I let x okay, so you see my box? Oh, what's wrong with this? You're gonna get on my nerves. Thank you. Man, it shouldn't have been that hard. Okay, so here's my box with the square base. That don't look like no box. Sometimes my system just don't want to act right. It drives me nuts. It's really a great system, but when it don't want to act right, it does whatever it wants to do. Like now, okay. I'm tired. I'm tired. I'm tired. I'm tired. And see, I got a problem. I like straight lines. And so that is hard for me because I want straight lines and it don't want to act right. There we go. Okay. So there's my box. This side is X, this side is X, this side is Y. Okay, so the volume of the box is X squared Y. Okay, so now it says to me that it wants to change. So originally, my X naught and Y naught originally X equals 5. So X naught is originally 5 and Y naught is originally 10. So my Z naught or my F of X naught Y naught is 5 times 5 times 10, which is 250. Now the question is, they want me to estimate the volume of the box. That means they do not want, so what they don't want they do not want me to put in 5.1 squared and multiply it by 4.9. Okay, that's what they don't want. They want me to estimate it. So they want me to say F of 5.1, 4.9 is equal to F of 5 and 10. Okay, wait a minute. Something's wrong. This should be 10.2 and 4.9. 10.2. So X is 4.9 and Y is 10.2. So I don't know where I got these numbers from.
Wait, can you go up some a little bit, please?
Okay, I don't know where I got 5.1 from. So they don't want me to take 4.9 and square it and then multiply it by 10.2. That's not what they want me to do. Okay, you want me to go up?
Mm-hmm. Okay, I just wanted to make sure.
They want me to use this formula. They want me to approximate it by knowing what I already know. So that plus I need the derivative F sub X at X not at 5, 10 times 4.9 minus 5 plus F sub Y at 5, 10 times Y, which is 10.2 minus 10. That's what they want. So F sub X is 2XY. Okay. So F sub X at 5, 10 is 2 times 5 times 10. That 100?
Yes.
Okay. That can't be right. Okay, and F sub Y, oh, we didn't do F sub Y yet. F sub Y is X squared. So F sub Y at 5 and 10 is 25. Okay, so here we go. So now we get F of 4.9, 10.2 is going to equal F of 5 and 10. We said that was 250 minus 100 times 4.9 minus 5 plus 25 times 10.2 minus 10. 265. So that's the estimate of what it would be. What's the true value? So let's just calculate it. The true value would be 4.9 times 4.9 times 10.2. Oh, that's a terrible estimate. What did I do wrong? That's terrible. We did something wrong here.
So what in the
something went in wrong. So X is 4.9. So the bases went down to 4.9, 4.9. And then the height increased to 10.2. Okay, so yeah, that's a terrible estimate. Something's wrong. Okay, so we want F of 4.9, 10.2 should be F of what we originally knew, which was 510. So F of 510 is, do we do that right? 5 times 5, that's 25.
510 is 250.
That's 250, okay. Did I put 250 in there? I put 250 minus, okay, so F sub X is 2xy. So 2xy is 2 times x, that's 2 times 5. That is 10 times 10 is 100. That's right. Did I put in 100? Oh, that's what's wrong.
What?
This is supposed to be plus. Woo, much better. Okay, I knew something was wrong. Okay, so this is the estimate. And that's the true value. That's pretty darn good now. It's supposed to be nice, not that many points away. Okay, I said I knew right away I did something wrong. Okay, here's another one. Italian ice. Which I just ate. Maybe subconsciously when I was looking over my notes, I saw the Italian ice and I had to get up and get one before I could teach class. Italian ice is put into a paper cone with a radius of 3.1 inches and a height of 4.9 inches. Approximate the volume of the ice. Okay, so for this one, we need the volume of a cone. And the volume of a cone is pi r 1/3 pi r squared h. So the volume Z is 1/3 pi r squared h. So that's the formula. And then we need Z sub r is going to be 2/3 pi RH, and we're going to need Z sub H, which is 1/3 pi R squared. Okay. So now it's easy to calculate if X naught is 3, I'm sorry, if R naught is 3 and H is 5, that's fairly easy answer to figure out, because Z equal to F, Z naught equal to F of 3, 5 is 2/3 pi, R is 3, and H is 5. So that's 10 pi. And then Z sub R of 3, 5. No, I did this wrong. This should be 1/3. This is wrong. I did the Z sub R. Z sub R is 2/3 pi. R is 3 and H is 5. So that's 10 pi. And Z sub H at 3, 5 is 1/3 pi times 3 squared. So that's 3 pi. And then Z naught itself is 1/3 pi R squared times H. 15 pi. So therefore, an approximation Z equal to F of R and H is going to be F of 3 and 5 plus Z sub R of 3 and 5 times, and I think it was 3.1, 3.1 minus 3 plus Z sub H of 3 and 5 of H is 4.9 minus 5. So this turns out to be 15 pi plus 10 pi, and then this is times 1/10. And then I'm going to get minus 3 pi. And then this is negative plus, this is negative 1/10. So that's going to give me 16 pi minus 3/10 pi. (157) pi over 10.
Mm-hmm.
You agree?
Yes.
Okay, so let's see. So what is 157 pi over 10? Where did my ruler, my calculator just go? I don't know what I just did with it. Oh, that's frustrating. And I have this pink calculator so that I don't lose it because it's pink. And so it should stand out on my desk. And I honestly don't know.
It's like 49.
What'd you get?
49.32.
49.32.
Mm-hmm.
Okay, so what did we get for if we took the actual real value? The true value would be 1/3 pi. R is 3.1 squared times 4.9. Pi divided by 3 times 3.1. Ooh, girl. 49.311.
Oh, that's close.
That's pretty good. Okay, so using this approximation is not a bad thing if if you're trying to estimate something. Okay. All right, I think you got the hang of it. You good on this?
Yes.
Okay. My favorite section. Here it is. Okay.